So, all right. So let's work through this problem. And here's what it says. It says when a field goal kicker kicks a football as hard as he can. Now keep this in mind, as hard as he can at 45 degrees. So what that's saying here is he is kicking it right now at his maximum. Because I remember reading this problem that later on, and there it is, it says what is the maximum speed? So they're really just saying what is his speed right now when he's kicking it as hard as he can. So it's at 45 degrees to the horizontal. The ball just clears the 3-meter high crossbar. So down here in the picture here, we've got this is 3 meters, and it's just going to clear it. Okay. The goalpost is, and so the distance horizontally is 45.7. Okay. So keeping that all together, and I'll just read A, what is the maximum speed that the kicker can impart on the ball, the football? I'll read the other questions in a second. But I would say, all right, here's the picture. Ball gets launched, flies through the air. The horizontal distance is the 45.7. And at that point, it just clears. So it must be 3 meters up above the ground. And my hint, and continues to be the same hint, is start the problem by dividing your paper in two and say, all right, I've got X and Y motion. And then write out the things that you do know. One of those might be, where are you going to put your origin? And one common place is right where the object gets launched, but another place is the ground. And fortunately for this one, those are one and the same. Because the field goal, and I guess you got to know a little bit about the game of football, but, they place the ball down on the ground, they hold it, and the kicker comes along and kicks it. So with that in mind, that would tell me that the position initial, both X and Y, is 0. The other thing to always remember that once you have a projectile, they're telling you the acceleration of it. And there's two of them. There's one in the X and one in the Y. So the acceleration in the X direction is 0. In the Y direction, it's negative 9.8 meters per second squared. Now, the other thing that they've told you kind of indirectly here, well, maybe I shouldn't say they told you, is that the initial velocity in the X direction is this unknown initial velocity that they're trying to get us to solve for, but multiplied by cosine of 45 degrees. And likewise, the initial velocity in the Y direction is the initial and then sine of 45 degrees. All right, so keeping that in mind, those are kind of the three things that they've given us for each the X and the Y. And then I like to start off with the second kinematic equations, and maybe not all the time, but any problem where there doesn't seem to be anything of given or needed for the final velocity, because kinematics equation number 2 is the one to use when you don't know or want the final velocity. And so we know things about distances, we know things about angles, we know about initial, but we have no interest or knowledge of what the final velocity is, either X or Y. And so that's why I would pick equation number 2 to get started here. And maybe you've seen this a few times. Hopefully it's beginning to kind of settle in that the X motion is kind of boring in the sense that the last term and the first term are 0. And so the only one that's not 0 is right here, and I can replace that with V naught cosine of 45t. And now I'll put in what I know, and I guess I've kind of started. I already put a cosine of 45. If I grab my calculator, I don't expect you to remember it, but cosine of 45 degrees is that magic root 2 over 2, so 0.707, and then initial velocity multiplied by time. And if we think of the time as being the time to go all the way to the goalpost, then that means it would correspond to an x value of 45.7. And so maybe one more step over here on the x motion before I go to the y motion, and that is to say, take the 45.7 and divide by 0.707, and you get a 64.6. And so I would say, all right, what I have so far is one equation with two unknowns. And just to kind of remind ourselves of math, you can't solve for those. There's an infinite number of answers. It would be like saying, what two numbers multiply together to give you 12? Well, it could be 1 and 12. It could be 2 and 6. It could be 3 and 4. They don't even have to be nice integers. Anyways, there's an infinite number. So two unknowns in one equation is not solvable. There's just an infinite number. So hopefully over here on the y motion, we'll be able to have a second equation. Then we'll have two equations, two unknowns. In a math class, we'd call that a system of equations, and we can now solve it. Okay, so let's apply our thinking to the y motion. Now for the y motion, when it crosses the goalpost, or I guess the crossbar at the goalpost, it's 3 meters high. The initial position in the y is 0. The initial velocity in the y direction, well, that's this term up here. So let me put v naught, and for the moment, I'll just put sine of 45. But to remind you, in case you've forgotten, it doesn't matter, we've got our calculator. Sine of 45 and cosine of 45 are that same magical 0.707. So that's what I'm going to put here in a moment. And the acceleration in the y direction, as we mentioned earlier, is negative 9.8. So I'll put the negative and then the 9.8, but half of the 9.8. So that's 4.9t squared. And of course, now if you look at this, although maybe I'll do one more step, I'll drop the 0. I'll put the 0.707 for sine theta. I'll put v naught t, I'll go minus 4.9t squared. And then notice that this equation, I'll put a little circle around it, has the same two unknowns in it as a v naught and a t. So now I've really done all the physics I can do, and now it's just a matter of math. And so like all of our system of equations, we want to combine the two equations together and hopefully in the process eliminate an unknown. And the easiest way to do that is a method called substitution. That means solve this equation, or this one, doesn't matter, for one of the variables. So in this case, I will solve this equation for time, and then use that into the other equation so you won't have time left anymore. So let's see what happens when I do that. So this has 3, and then there's the 0.707. There's the initial velocity. And right here where it says time, I'm going to put 64.6 over initial velocity. And then minus the 4.9, and then this will be time squared, and again, time would be 64.9 over V naught. So, of course, now you should be looking here at an equation that doesn't have time in it anymore. And so now we can solve for V naught. And let me continue on. So this would be 3 equals. In this first term, there's a V naught in the numerator and the denominator. And so if I take the 0.707 and multiply it by the 64.6, I would get a 45.7. So 45.7. And this one, I've got a bunch of factors. I'll start with the 64.9 and square it. And then multiply by the 4.9. And that looks like I got 20,639. And in the denominator, I have V naught squared. All right, so maybe I'll take this third term here and move it to the other side. So 2,639 over V naught squared. And then over here, I'll move the 3 to be subtracted away from the 45. So this would be 42.7. Maybe I'll write it as a cross multiplication. So I'll put the 42.7 over 1. And then when you multiply these, you get the 42.7 V naught squared equals the 20,639. Now, continuing on here, I'll just grab my calculator for this because here's the 20,639, and I'll divide it by the 42.7. I'm going to move that over. So that would be the initial speed squared. And so then let me finish by taking the square root. And so I would say V naught is equal to 21. And it looks like if we go with, let's see how many significant figures. Now they say 3 meters high, but I think they mean exactly 3 meters. I think it is. No, it would be. I think it's supposed to be exactly 10 feet, which is pretty darn close to 3 meters. But I'm going to go with the 3 as being more than just one significant figure. The way they wrote it, you could argue that they mean just one. But I'm going to go with they mean 3. So my 0.985 would boost up to 22.0 meters per second for the initial velocity of this kick. And as I mentioned earlier, then, that initial velocity is also the maximum this kicker can kick it. So there's A. What is the maximum speed the kicker can impart to the football? So if I keep going to B, in addition to clearing the crossbar, the football must also be high enough in the air during its flight to clear the reach of the on-rushing defending lineman. So that's what this picture is. So you got to make sure when you kick it, you get it kind of up high and above the defense. Otherwise, they're going to block it before it even travels much of a distance. So in addition to clearing the crossbar, the football must be high enough in the air during its flight to clear the reach of the onrushing defensive lineman. If the lineman is 6.4 meters away and has a vertical reach of 2.5 meters. So I think what they're saying by vertical reach is as measured from the ground, the lineman can reach up 2.5 meters. And the lineman is, let's see, in addition to clearing the crossbar, the football must be high enough in the air during its, or early during its flight, to clear the reaches of the onrushing defensive lineman. If the lineman is, there it is, 4.6 meters away and has a vertical reach at 2.5 meters, can he block this 45.7 meter field goal attempt? So why don't we kind of rethink this problem? So I'll go X and Y. And as I rethink it, we have figured out the initial speed. So keep that in mind. I'll even point out we know their positions and acceleration and initial velocities. In fact, maybe I'll get my numbers. So my initial speed in the X is 0. My acceleration in the X is also 0. My initial velocity in the X direction would be this 222 meters per second times the cosine of the 45 degrees they're kicking it, which would be that statement right there. All right, so let me get a number here. This number then would be 22 times the cosine of 45. And we're looking at 15.6. So 15.6 meters per second is the horizontal speed. Initial. And even though I say initial, it's also what it is later on, because there's no acceleration in the X direction. In fact, that's probably worth putting on here also, like we did in the first part. And kind of in the Y direction, we can play the same game. We know the initial position in the Y direction is, right above the field, right where we're kicking it from. So that's the initial position. The acceleration in the Y direction is a negative 9.8. The velocity in the Y direction would be, we'll go to the first part, V naught times the sine of 45. And I keep saying it 0.707. I should at least double check. Yeah, 0.707. Okay, so the initial speed would be the total speed, 22.0, then multiplied by cosine of 45. I think I forgot to write cosine of 45 over here. But it looks like I calculated it here. And then over here, I just wrote out the calculation. I didn't even write out the symbols. Okay, so the initial speed being 22 and the cosine of 45 being the 0.707 gives me, oh, this should be the same thing, 15, oh, not the y, not the acceleration, sorry, 15.6 meters per second. And since it's 45 degrees, then, both the sine and the cosine are the same number at that angle, and then the initial velocities x and initial velocity y's are the same. So hopefully not a big surprise there. But to see if it clears this defensive lineman, it says, in addition to clearing the crossbar, the football must be high enough in the air during its flight to clear the reach of the onrushing defensive tackle or lineman. If the lineman is 4.6 meters away and has a vertical reach of 2.5 meters, can he block this 45.7 meter field goal? So why don't I do this? Why don't I ask, how high is the football when they get to the player, which is 4.6 meters away? So coming back over to here, if I'm going to ask how high it is, I guess I would want to use this kinematics equation number 2, because it does give me its height. Now, sadly, I can't do it without the time. However, I would say that I can get the time from a horizontal motion. So let's try the horizontal motion. And I'll just kind of squeeze in a +0 because this last term is related to the acceleration, which is 0. And the first term is 0. So this would say the position in the x-axis would be its initial speed I guess I don't want to do that. I'm sorry. Cosine of 45. Initial speed times cosine of 45, which is the initial speed in the x direction. That's what I was trying to write. So this is the 15.6 t right there. Those are 0. Those two together, the angle and the initial speed, come out to be how we got the 15.6. So coming back to my picture, if I then put in 4.6 meters for the football, that would give me an equation to solve for the time it takes for the football to get there. Then if I know that, I can put it into this equation here, which would then tell me how high is it. And I'll see if it is out of the reach of the defensive player. So putting in 4.6 meters here and solving for time, so 4.6 divided by 15.6 comes out to be 0.295. So a lot of these problems, my hint would be know that you can, move the time, because there's no such thing as an x component or a y component of time. So if you can solve it in one column, you can then move it to the other column. And some problems you solve for time in the X, which I just did, but other problems you solve it for Y. It really depends if you know final speed, and then you can solve for time. Or not final speed, final position. And so we know the final position in the X direction. What we're trying to find is what it is in the Y direction. So once we have time, we can start to put in what we do know. And we know that the football starts with an initial height of 0, since we're kicking it off the ground. The initial velocity in the Y direction is that 15.6 that we did up here. Then multiply by a time of 0.25 plus the negative 9.8. So this acceleration, which as we said is a negative 9.8, together with the half makes a negative 4.9. And then I can put in that time again, 0.295 squared. And this should tell me the height of the football. So 15.6 times 0.295 is a 4.602 meters minus 4.9 times 0.295 squared. And so that is minus a 0.426. And of course, you can see that it's still going to be over 4 meters. And I think they're saying the linemen can clear or reach up to 2.5 meters. So this is way above that. 4.602 minus 0.426, coming up with a height of 4.18 meters. When this is all said and done, how high is it? Now, I do want to be careful about this vertical reach. Because does that mean the lineman can only reach up to 2.5 meters? That's, well, I guess okay. I guess no. Okay, I was thinking that wasn't very high, but man, that's reasonably high. I bet in reality it's a little higher than that, but okay, not too much. All right, so 2.5 meters. Anyways, the football is way up there. It's at 4 meters. So this lineman can't get it. So let's see. In addition to clearing the crossbar, the football is high enough in the air during the flight to clear the reach of the onrushing defensive lineman. If the lineman is 4.6 meters away, has a vertical reach of 2.5 meters, can he block it? And so I guess no. Too high. So of course what the defense person wants to do is get closer in, because the football's down lower and they might be able to reach it. And so that's what this next part, it says, so what if the lineman is only 1 meter away? And so maybe I'll just kind of do this second calculation in kind of a blue here. But the difference would be right here, where I would put just 1 meter. Because everything else in the X would still be the same. It would still have the same horizontal speed. And so, of course, that means the time it's been in the air would be much shorter, which is why you're closer and why it's not going to be as high. So if I take 1 and divide it by 15.6, we're talking about a time of only 0.0641 seconds. So when we take that time and put it into our equation here, we can say y equals, and so the initial height is still 0. That's the kicking of the football. The initial speed is still 15.6 in the upward direction. But what is very different, now that we are so close to the football, is the football is not going to have much time to travel. And so this number here won't get quite as big. Although I guess you might also say, well, but you would also not be subtracting a very big number. Okay, fair enough. But this one's going to dominate it. You're going to see that it is much lower than the 4 meters. And I think definitely within the reach of the player. But let's see what kind of number I get. So 15.6 times the last answer, minus 4.9 times the last answer squared, and almost 1 meter. 0.9. I go 3 significant figures, 80. So it's only a meter, actually a little less, off the ground. And easily going to be blocked. The defense, I mean, so close the defense doesn't even have to lift up. It's gonna hit them right in the waist. All right. Well, hope that helped.